Hello boys and girls, and welcome to lesson 3-9, angles in any polygon. To begin with, this is on page 89 by the way of your math journal. To begin, I want to show you a trick or an equation that we can use to solve the sum of all the angles in any polygon. When I mean the sum, it means you can add all the angles inside the shape of the polygon and it'll give you what they all equal when you add it up. So the angle of the sums, okay? And we first have to count the number of sides and then how many triangles it will have inside that shape, and we will outline or state what is the sum of all its angles. So let's work with this. Please, if you can, and you have a piece of paper in your notebook, make a table like this. Across the top, make three columns. These three columns: angle of number of sides, number of triangles, and angle sum. And then along the side, draw these three polygons. Draw the triangle, the square, and the pentagon. You can continue on afterwards to keep trying. You can draw a hexagon, a heptagon, an octagon, and so on. Okay, so let's go ahead and try this. Let's begin with the triangle. A triangle has a number of sides. Well, it has 1, 2, 3. So we have 3 sides. And how many triangles do we have in a triangle? Well, just simply 1. And what is the sum of all the angles? Well, as you know, boys and girls, a triangle will always equal 180 degrees. Because you can pretty much see that a triangle is a half protractor. Okay? If this is the bottom of your protractor, it's going to go around like a rainbow like that, and you know that here is 0, at the very top is 90 degrees, and on the side it's 180. So it makes the entire rainbow, or the arch, all the way around to 180. So you understand that the sum of all of these 3 angles will be 80. If it's an equilateral triangle, it will be 60 plus 60 plus 60. So we can state this, and we know this already. With this square, okay, how many sides do we have on a square? 4 sides. How many triangles can we fit? Well, in order to follow the rules of how we're going to draw triangles, we cannot cross lines as so. Let's say we have a square. We cannot cross lines as we have done here. We also cannot, the line has to go all the way across to the other side as we've done here like this, and so on. It has to make it all the way across. It cannot just go to the middle and then go back out. So really, what we can do is only draw one line, as so. Right across the middle. And you can see that we have 1 and 2 triangles. So we actually have 2 triangles. If one triangle equals 180 degrees, 2 triangle is going to be double 180 degrees. And we know that 380 degrees times 2 equals 360. 360 degrees. Okay, let's do the pentagon. Pentagon has 5 sides. Okay, and how many triangles can we fit in the pentagon? Okay, I can go from here and draw one there. Okay, and then split this one to draw another one there. So I have 1 triangle, 2, and 3. I have 3 triangles, and well, what's 3 times 180? You should have 540 degrees. Okay? Let's see if we find a pattern here, boys and girls. Okay? When we have 3 here, we have 1 here. 4 here, 2. 5, 3. What is the difference between all of these numbers? If you said -2, you are correct. So here's the trick. Count the sides to any of your polygons, subtract 2, and you'll get the number of triangles. Then the number of triangles, simply multiply it by 180. Okay? This would be 2 times 180 equals 360. 3 times 180 equals 540. And you can do this with any polygon, regular or irregular. So count the number of the sides, subtract it by 2 so you know how many triangles are in it, and each triangle in that polygon is worth 180 degrees. So just multiply that number to 1 times 180, or just simply add all of the 180s, each triangle together. For number 1, we are asked to draw line segments from vertex is the little corner, A, of this octagon, so octagon meaning 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's clearly an irregular polygon. And you're going to draw from vertex A of the octagon to each of the other vertices except B and H. So what they're asking us to do is to take our pencil and draw from A to all the other vertices except B and H. So let's try that. Please use a straight edge. I do not have a straight edge, or I cannot use a straight edge on the screen, but you certainly can on your paper. So you're going to draw right to each vertices as so. Okay, and stop there. Yeah, I drew a line segment. To all the other vertices, these ones, except B and H, not B and not H. And the reason I didn't do that is because I'm just simply trying to draw as many triangles as I can squeeze in. If I draw a line from A to B, I'm just going to draw over this line. Or from A to H, I'm going to draw over this line, and that's not a triangle. So we can see, boys and girls, the triangles that we have drawn in this image. We have 1, 2, 3, 4, 5, 6. Does that work? Let's see. According to our plan, we have to count the number of sides first to the octagon. And we counted 8. So we have 8. And we're going to subtract 2 so that we can get the number of triangles, right? So we have 6 triangles. Let's see, is that right? 1, 2, 3, 4, 5, 6. That is correct. So now that we have our 6 triangles, we need to take our 6 triangles and multiply it by 180, because each triangle has 180 degrees. Once you have multiplied this, boys and girls, you will have your answer for question A, or question 2. How many triangles did you divide the octagon into? We divided it into 6. What is the sum of all the angles? Multiply 6 times 180, and you will have the sum to all of them. Question 4. Ignacio said the sum of his octagon angles is 1,440. Below is the picture he drew to show how he found his answer. Explain Ignacio's mistake. Well, take a look at his picture. He drew all of these triangles, but his line segments are not going. Remember, this was supposed to be A right here. This was B, and this was H, right? The instructions said that he had to go across to all the vertices from A. He had to go all the way across, right? He did not do that. He kind of just went to the middle and drew out many more triangles. So he broke the rule. He didn't make a line segment all the way across without intersecting. So these are not intersecting, but they're ending right in the middle. So that is a mistake. It's going to give him more triangle than he should have. So let's go ahead and copy that down here, our explanation. This, boys and girls, will be your key answer. Ignacio should have drawn lines from one vertex, such as A, to each of the other vertices, as so. Instead of drawing a line between each vertex and some random point in the middle, as he did here, he just picked any random point in the middle and he went from each vertex right to the middle. That was his mistake. Please star this answer as your key answer. For question 5, we read, a 50gon is a polygon with 50 sides. How could you find the sum of the angles in a 50gon? Well, we understand that we count the number of angles. The number of sides. We count the number of sides. That'll give us the number of triangles and our angle sum. So we have 50, they're saying. And we understand that we just have to subtract 2 from 50 to get the number of triangles. So that would be 48. And we take that 48 and we multiply it times the sum of the angles of each triangle, which is 180. And that'll give us our angle sum. So go ahead and solve that and write down your explanation. Sum of the angles for a 50gon would be whatever you find here, 48 times 180. Okay? And explain how you found this by simply explaining this. A 50gon can be divided into 48 triangles. The sum of the angles would be 48 times 180 degrees. Okay, go ahead and solve that, boys and girls. For page 90, we have a review, practicing expanded notation. This is something we have done earlier this year. You can also use your student reference book if you brought it home with you. If you have not, let's just do one and you can do the rest the same way. Use the place value chart on 396 of student reference book to help you write the following numbers in expanded notation. So let's do 982.04 in expanded notation. We have to look at the value of each number. So, for example, if we look at 982, we know that we have the number 900, the number 80, the number 2, then we have 0, which is a placeholder in the 10th, and 4 in the 100th. So, let's add each value of the number to make an expanded notation. So we have 900, okay, plus 80, plus 2, plus, well, we can't put this because we're not going to add 0, but we can add the 4, plus 0.04. And that is our expanded notation. Go ahead and try that with 1, 2, 3. Okay? For number 5, build a 4-digit number. Write the 3 in the 100th place. Okay? Let's see here. You have not been given a decimal, so you have to solve where the decimal lands. 4 in the 10th place, 6 in the 1's place, and 9 in the 10th place. So you have 2, 1 in the 10th and 1 in the 100th. So 2 on one side of the decimal and 1 in the 10ths and 1 in the 1's. And 2 on the other side of the decimal, in the whole numbers. So you have 2 decimals and 2 whole numbers. So where does this decimal go? For numbers 6, 7, A, and B, we have to now go backwards. Here we're given the expanded notation, and we must write it in standard notation. We have 654 279 thousandths. Okay, go ahead and write that down. And let's use these clues here. Okay, what is 3 squared? It's 9. Okay, and so on. Figure out these clues here to write in your number. Okay, and finally, write this number in expanded notation. The number that you have solved here from these clues in expanded notation. Okay, boys and girls, we will check this, page 90 and page 89 in class.